Electromagnetic induction. This is part 2 now. What is the definition of this phenomenon? So the phenomenon of electromagnetic induction, it's a phenomenon in which changing magnetic field across a loop results in the generation of induced electromotive force, and this is what we call voltage. In order to have a voltage, I take, for example, a dry cell, plus and minus, and here we have the dry cell. If I put it in a closed circuit, then I will also have a current, which is called the current I. Now, in the electromagnetic induction phenomenon, it's a process where I have a voltage, electromotive force, but without even having a generator. And if the circuit is closed, if I have a closed loop, then I will also get a current. But this current, in this case, I don't name it only current, I name it the induced current I induced, since it's not due to a dry cell. So the electromagnetic induction phenomenon is a phenomenon where I have induced electromotive force, and if the circuit is closed, I will get an induced current, but without the use of generator. So what are the conditions in this case? كيف بيطلع عندي هيدا induced current or this induced voltage? By experiment, we did many experiments. من ضمنهم, if I take, for example, a magnet, وبجيب لهيدا المagnet from the coil, بلاحظ إنه we will have على galvanometer, I will have a deflection of the galvanometer. And then if the magnet becomes constant, it's not displacing, then بلاحظ إنه there is no deflection, there is no current. When I move away the magnet, then I will notice that we'll have a deflection. لما بيرجع stable, there is no deflection. So this is the first case. The motion, the relative motion of the magnet across the coil will result in a current, and this is what we call an electromagnetic induction phenomenon. This is what we were talking about. So لما بيجي بعد المagnet عن الكويل بنلاحظ we'll have, due to this motion away, we'll have the creation of a current. Now, when I move the magnet towards, we'll have also a creation of current, but we notice that the direction of the current will be opposite, will change. In the last case, when there's no motion, لما بإيدي بتكون ثابتة, I'm holding the magnet, but there's no motion, we notice there is no value of the current. So ما في عندي current in this case. So in order to have the electromagnetic induction phenomenon, كان عندي a relative motion of the magnet across the coil, which will result in a variable magnetic field. And when I reverse the direction, moves away or towards, بنلاحظ إنه the value تبع electric current will be reversed. And at the end, if the speed, كلمة speed تبع الموشن اللي بتكون أكبر, then the rate of the electric current will be more. So this is the first case we noticed. In order to have an electromagnetic induction phenomenon, we must have a value of B which is variable. Second case, in order to have electromagnetic induction phenomenon, for example here, we notice when the surface is changing, when the area is changing, so we are having a phenomenon of electromagnetic induction. When the object is inside, when the loop is inside the magnetic field, we notice that the area is constant, so ما بيطلع عندي electromagnetic induction phenomenon, there is no current. And when it's moving out, كمان the surface is decreasing, so we notice that there is electromagnetic induction phenomenon. And here the last one, لما بنلاحظ هون على galvanometer, when I'm rotating this loop, okay, then in this case we're having a current, an electric current. This is what we call the induced electric current. This means when I'm changing the angle between the magnetic field and the loop, then we're having a electric current, so we're having an induced electromagnetic induction.